Hey class, welcome back. We're going to be talking today about today's notes and the movie version of this book right here, The Martian. And if you check out the notes behind me, it's kind of a cut down version of the notes that we had in class. I kind of erased those, put it down onto one screen here. Wanted to do something a little bit different as we move into Thanksgiving week. And I usually try and use this movie around this week if possible, because this movie, we're doing the movie version, by the way. The book adds a little bit more detail, of course. But we're doing the movie version because it's a very good way to bring together some of the things in Chapter 4. If you look at the beginning of Chapter 4, which we're starting right now, the very first paragraph or two talks a little bit about having, you got to bring together chemistry, geology, astronomy, all these things in the study of life. Well, when we're doing that with this book right here and this movie, The Martian, they do a pretty good job of it. And of course, it's always fun in movies to check out, what they do well and not so well and things like that. This is a 2015 movie by Ridley Scott. Don't tell them I'm using clips from it because, copyright and all that, so we'll keep it between us. But if you check out very, very quickly, one of the things that we started off with in all the classes today was talking about this term here, the Goldilocks Zone. If you check out the terrestrial planets, Mercury, Venus, Earth, and Mars, you've got rocky planets that are close to the sun, and you hear this term quite a bit. It comes up in a couple of our readings I wanted to point out specifically, because we all know Goldilocks and the Three Bears. You've got the perfect porridge, you've got the too hot, too cold, and just right. When they're referring to Goldilocks Zone here, they're talking about water. They're talking about being just the right distance from a star so that water can exist in the liquid form. Now, water is amazing. We've talked a lot about H2O having a wide range of temperatures at which it's a liquid, as opposed to many other substances that don't do that. That's incredibly important, and we think in the search for life out there, finding liquid water is the key. And of course, here on Earth, we've got liquid water. We've got 70% of our beautiful planet covered by oceans. That's what we're looking for when we're looking for life beyond Earth. So that's what they're talking about with the Goldilocks Zone. We did a quick brain pop on Venus as a good comparison. If you check out Venus, Venus doesn't have a magnetic field to protect us from solar radiation. We'll talk about that a little bit more in detail later when we do a little bit more with this state of matter called plasma. And also Venus has often been called our sister planet. It's about 90% the mass of Earth. If you went there, in other words, you would weigh just about 10% less. Very close in terms of size. And when they first started to check out Venus, scientist Galileo, of course, was referred to because he was looking at Venus through his telescope, noticed it had phases like the moon. When telescopes got better and other astronomers started to look at it, they said, well, wait a second, Venus is covered with clouds. You might remember, for example, this book, short story that you probably have read already, although it's usually assigned somewhere around middle school. It's called All Summer in a Day. And in this story, they have Venus being colonized by people. This girl in the story, the protagonist of the story, is looking forward to the one day a year when the sun comes out. Don't know if you remember the story or not. The point is, they looked at Venus and they thought, wow, clouds all over it. It must rain there all the time. It must be like swampy. Maybe it's like a big rainforest all over the planet. Not even close. It turns out they got this one completely incorrect. People who were thinking about Venus as being a swampy kind of forested area. When you look at Venus, you've got a cloud cover that is about 96% CO2, carbon dioxide. You notice down here further in the notes, we talk about CO2 and CH4. You know what these are already, which is great. So we don't have to put out the whole name, carbon dioxide and methane from their chemical formulas, which is great. Turns out, when we look at Venus through different light, and that's one of the things in Chapter 4 we start talking about. We've already touched on it, the spectrum of light. Light, visible light, like we're seeing right now when you're looking at this video, is just one aspect, one flavor, if you will, of light. Light has many, many different flavors: gamma rays, X-rays, microwave. We've talked about that. When they looked at Venus, they were able to figure out from the light that it's putting out a tremendous amount of heat in the form of infrared radiation. Now, the book and our readings and our one-page recap talks about the greenhouse effect. That is what everyone calls it. I tend to call it the hot car effect. Many of us maybe not have been in greenhouses, but you've probably at least had the experience of going into a car like here in Pacifica today. I'm pointing out the window. It's a gorgeous day. It's like 60 degrees. It's pleasant, kind of warm, but not like, blistering hot, of course. But if you go out to a car that's been sitting in a parking lot for a while and the windows in that car are up, it's very, very hot inside that car. If it's been sitting out in the sun in a parking lot, it heats up very, very quickly. Same thing with a greenhouse, by the way. You've got solar radiation. This is why they say, never leave your pets in the car. Even if it's a fairly pleasant day outside, very quickly, when the light comes in, the visible light comes in, when the radiation comes in through the windows, it's transparent to that sort of light, the windows hold in the infrared radiation. If you check out the spectrum of light, we've seen the rainbow of light drawn on the board before. Infrared literally means below red. Our eyes can't perceive it, but we feel it as heat, below red, infrared. And inside a car, as you probably know, it gets very, very hot very quickly if you leave the windows up and you leave it in the sun. That is the basis of climate change here on Earth. If you look at these two gases, earlier in the week, we talked about fossil fuels. Fossil fuels, when we burn fossil fuels, we're releasing a lot of CO2, a lot of CH4 into the atmosphere. This acts a little bit like the windows of a car. Now, it's important to note that a greenhouse effect, a small one, is a good thing. It keeps our planet comfortable. It keeps our planet just the right temperature for life and liquid water, which is the Goldilocks Zone again. But at the same time, one of the big things that we worry about is putting too much of this gas in the atmosphere increases the levels higher than what they would normally be, and you're keeping in more heat. This is the basis of climate change. Our climate, our atmosphere is getting warmer because we're holding in more infrared radiation from the sun. A couple other things that we talked a little bit about was the Mark Watney's, when he gets stuck on Mars. Now, of course, I'm not really giving much away to let you know that in the very first scene. Again, I'm chopping it into little itty-bitty scenes and talking about it just in tiny pieces. Of course, with distance learning, we don't have time to sit back and watch the entire movie. He's left. They think he died on the planet during a big windstorm. One thing they don't quite get right about the science, because Mars, and it was one of our facts here, Mars has an extraordinarily thin atmosphere. While the wind does blow there and it creates these giant dust storms all over the planet, it's not enough really to push you around like they show in the movie. One of the things that happen when he gets stuck there and they think that he didn't make it is the other astronauts, his partners in the movie, they have to leave. They think that the astronaut, their friend, has not made it. Obviously he does, or you wouldn't have much of a story. It would be a little bit like Indiana Jones getting run over in the first 5 minutes by that giant boulder in the first movie. If that happens, if you don't have a protagonist trying to survive, you don't really have much of a movie. No, he does make it, of course, but then he's got the gigantic problem of trying to figure out how he's going to survive 4 years, because the next manned mission to Mars, this book is supposed to take place about 25 years in the future. The next manned mission is supposed to arrive at Mars in 4 years. Even if he stretches out his rations, he has to figure out how to make it that far because he only has enough food for 1 single year. Two quick things, and then we'll call it a day here. In terms of storytelling, they throw in 2 scenes, and remember, in good storytelling technique, if you have any scene in a book or in a movie, if it's a good movie and a good book, every single scene, every paragraph, every word should contribute to the story as a whole. You don't want to put in a lot of filler that doesn't really mean anything in terms of the story. There are 2 scenes that you might wonder about. One, it shows Mark Watney at one point, played by Matt Damon, taking off his shirt as he's walking through the habitat that they have there on Mars. You might be thinking, well, why did they put a scene in like that? Why do we have to see Matt Damon taking off his shirt and walking around shirtless? Good reason for this, and again, tie in with chapter 4. We talked about the 4 biological molecules: carbs, carbohydrates, proteins, lipids, and the nucleic acids. Later on in the novel, and I'm not really giving away too much here, later on in the novel and in the book, he's running low. Mark Watney, the fictional astronaut in our story, is running low of protein. He's growing potatoes on Mars, and we'll talk about that in just a second, but he's growing potatoes on Mars to add to his rations. but he's got a very low protein diet. Remember, proteins are the building blocks. You don't get enough protein, very quickly your muscles would do that. They have another actor as stand-in who's very, very skinny. Stand-in for him is roughly the same height, but is extraordinarily skinny. You don't see him from the front. And they do a good job of depicting what would happen if you didn't have enough protein in your diet. Also, one of the other scenes that they throw in, and again, this gets to the growing of the potatoes, they show a scene right towards the beginning, right, I think like his first day, the first Sol, which is a Martian day, that he's stuck there, and it shows him coming out of the bathroom. You're like, well, all scenes, why show that? Well, remember, dirt and soil, this goes back to our reading. Remember, look for your one-page reading, look for our notes at pacificascience.org. Dirt and soil are not the same thing. Mars is covered with a lot of dirt, but it's not soil. Soil is really, you can think of it as a living thing, or it contains living things. Soil here on Earth, you pick up an average scoop of mud, it's got microbes, it's got nematodes, worms in it, bacteria. You're talking about really a living thing when you're talking about soil. So when it shows Mark Watney leaving the bathroom, when he's starting to think about how am I going to survive here, and by the way, this is why I show this around Thanksgiving time usually when we're doing biology, one of the supplies that they gave the astronauts in the movie and in the book is they sent them up there with some potatoes because the astronauts supposedly were going to be there over Thanksgiving. And so Watney thinks about this for just a minute. He's a botanist. He knows he can take those tubers and he can grow them. So long as he has soil, how is he going to get soil when he just has dirt on Mars? Mixes it with human waste. Ooh. But it works. And as a matter of fact, most scientists agree that probably this crude soil would be enough to grow potatoes on Mars. They've actually done this now in an experiment. They go into a little bit more detail in the book. In the book, they actually added some more organic material that they had in the habitat. But the point is, remember, dirt is just minerals, rocks. Soil is a living thing in terms of the things that are inside. You've got organic material, you've got microbes in there, and that's going to play a key part in us understanding Chapter 4. And I hope you're enjoying the way we're approaching Chapter 4 by doing the story of a fictional astronaut, played by Matt Damon, stuck on Mars and his effort to survive over being stranded there over a couple of years. Have a wonderful Thanksgiving break. Stay safe. Can't wait to see you guys back in the classroom one of these days. Please look for more of the notes and more explanations out there at pacificascience.org, of course, in your Google Classroom. And of course, I'll throw out a couple more YouTube videos over the course of our week off from school. Nothing that's due, but hopefully clarifications on Chapter 4 and some of the things that we've done. Take care, everyone. See you online. Bye-bye.